Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Human Eye and Colourful World. In the previous video, we learned about the parts of human eye and their functions. Today, let's learn about some defects of our eye. In our class, if you see, most of the students have specs now, right? How do you identify that, or how do you come to know that you have some defects of vision? Mostly, it is identified in smaller classes itself, and it is very easy. If the child is struggling to read something which is written on the board, when the child is sitting at the back, then that is an indication. So notes may be incomplete, or they are straining their eyes. Then sometimes the teachers may notice, sometimes the parents may notice, sometimes the child himself will be identifying that and bringing to the notice of the parents. So in most of these cases that you are all suffering from, not you are all, majority of you are suffering from, is called a myopia. Okay, myopia means what? Myopia, otherwise called a short-sightedness. As the name suggests, it is the sightedness or the vision of the short distance only. That means they can see the objects within the short distance, but far away objects they are not able to see. For a normal person, we learned our near point or the minimum distance at which we can see clearly is 25 centimeter. But the far point at which, or the farthest distance we can see clearly is infinity. That is for normal eye. But for these people, what happens is their far point or the farthest vision, it's not up to infinity. They cannot see up to infinity, but they can see some point before that. So their infinity, say their far point is nearer than infinity. It's not reaching up to infinity. It is just before that, or a few meters before that. Clear? So this is the condition. In this case, what happens is the image coming from the infinite object, which they are not able to see clearly. Why they are not able to see clearly? Because the image is falling not on the retina as usual, but it is falling in front of the retina. If it is not falling on the retina, can we see clearly? No, that is the reason. Okay, so why this is falling in front of the retina? There can be two reasons. One is excessive curvature of the eye lens. The eye lens, last class I told, if the lens is thick like this, means the curvature is more, so the focal length is less, power is more. But if the lens is thin like this, focal length is more, power is less. Okay, here what happens, the excessive curvature of the lens means the lens is very thick and the the focal length is very short. If the focal length is very short, it is not reaching the retina. It will converge where, it's a convex lens, so all the rays will converge at a point in front of the retina. That is the reason why they are not able to see. So if an object is kept here, this is infinity. So infinity, suppose if something is kept here, the image will fall on the retina, they will be able to see. But if it is from the infinity, what happens? It is falling in front of the retina, so they are not able to see. But we know that any defect like this, we use eye lenses, right? With a different power according to their need. So here, which lens to be used is the question. So here the problem is, due to thickness of our eye lens, our lens is converging the points very quickly, converging the rays so quickly. So if we can diverge the lights little bit, then the convergence can be even farther away. So that technique is used here. So if you are using a divergent lens, what is a divergent lens? It is concave lens. So for people with a myopic eye, concave lens with a suitable power is used. So once you keep a concave lens in front of your eyes with a suitable power, so what happens? The light coming from the infinity, that is the parallel line which is coming, which will be diverged little so that it is widened, then it is converged to the retina. Okay, as a result the image falls on the retina. So myopia is short-sightedness. They can see short distance clearly, far away objects are not seen clearly. For them, far point is not infinity, but it is before infinity or less than infinity. In this case, the image of the object is formed in front of the retina. Why? Because of the excessive curvature of the eye lens. But there is one more reason for this, elongation of the eyeball. These all can be due to congenital reasons by birth itself. If the normal eyeball is like this, the image could have fallen on the retina, but due to some reason the eyeball is little elongated. So the image is not reaching the retina. That could be the other problem. So either excessive curvature of the eye lens or the elongation of the eyeball can cause this disease, and by using a concave lens of suitable power can rectify this problem. And concave lens means what? Focal length is negative, so power also will be negative, because power means what? Reciprocal of focal length in meter. Let's now learn about the next defect of vision, that is hypermetropia. Here in case of hypermetropia, it is just opposite to what we learned in myopia. There nearby objects can be seen very clearly. Here nearby objects are not clear, whereas far away objects can be seen clearly. Because in this case their near point, which is supposed to be 25 centimeter, is not 25, little beyond that. Okay, so when it is moving away, when they are keeping at 25, they are not able to read, but if you keep little farther away, they are able to see. So here in this case, where is the image forming? Image is forming in front of, behind the retina, because in myopia it was in front of the retina. Here it is behind the retina. It goes beyond the retina. Why? Because either the lens is thin, because of it's not thick enough to converge properly, maybe due to by birth itself the defect is there, or ciliary muscles, so that it is falling. It's a focal, because thin means what? Focal length is more and it is falling there. Okay, or the eyeball is short. So normal retina it could have fallen, but the eyeball is short, so it is going beyond that. So two reasons are there: either the lens is thin, so that focal length is more, or the eyeball is very thick or short or very small. So how can we correct it? Here, if you use a converging lens of suitable power, we can converge it onto the retina. So for this people, this is the normal near point, but this is the receded or the near point which has gone far. So from here, if the light comes, it will converge onto the retina. But for this people, from this normal 25 centimeter, if it is coming, it will converge and go behind the retina and form the image there. So what can we do? We can use a converging lens of suitable power, so that this will converge the light coming from here. Suppose this is the light, it will be converged here. Okay, so convex lens is used, because convex lens is convergent lens of suitable power. And what is the power then? It is positive, because focal length of convex, X I told like this, convex is positive, so convergent lens has a positive power. So in hypermetropia, the far point is okay, infinity, but near point is not 25 but more than that. As a result, they are not able to see the nearby objects clearly. So in this case, either the lens is thin, that is focal length is more, or the eyeball is small. As a result, the image is formed behind the retina. And by using a convex lens of suitable power, we can rectify this defect. So in hypermetropic eye, the people are not able to see the nearby objects clearly. But this can be due to other reason also. It can be due to age-related factors. For example, after the age of 40, this 25 centimeter near point recedes away. Okay, but it is not hypermetropia, but it is due to age. Why we are distinguishing both this? Because hypermetropia due to some eyeball is small or lens is thin already, but here it is not because of that. Ciliary muscles are weak, because from time of birth it has been doing the contraction, relaxation and making the adjusting power of accommodation, all this we are doing. So now it needs rest, it has become very weak. So anytime when I am telling, okay, look at the close object, it cannot shrink. So my near point is not now 25, it is little away, maybe it is 40, or it keeps on going back. So now for me, far away objects I can see clearly, because I don't have myopia as such, but nearby objects I am not able to see. For reading, I need a reading glass, but this glass is a convex lens with a positive power, but this glass I can use only for reading, because when I am using this and if I look up, I will not be able to see the objects clearly, because that will become blurred for me. I don't need that. And this problem is called a presbyopia. But think of a person who already had myopia since childhood, or maybe from smaller ages or youth, but later after 40 he is developing this problem also. His near point also receding away. So it's a combination of both the problems he is getting. He can neither see nearby objects nor see far away objects. Right. So for reading he needs a convex lens, but for seeing far away he needs a convex lens. Concave lens he has already been using, so he needs now a combination of lenses. We previously we used to get a glass with a curved convex part at the bottom and the rest part is concave. So when you look straight it will be seeing like that, but when you look down you can see the nearby objects clearly. But so this is having two different focal length, that is concave is different, convex is different. This is called a bifocal lens. Yeah. But these days we do not have this kind of separate glasses. We have progressive lens, so we cannot make out which one, but it will adjust its focal length. Now another defect which already mentioned in the previous video, that is cataract. That is after 40 this is the problem happening, that is nearby objects are not clear. But after 60 there comes a milky cloudy appearance over your eye lens, that is called a cataract. For that we cannot rectify using any glasses. We have to go for a cataract surgery to remove that layer so that the vision is restored. So if you like all my videos, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.